In this video, we're going to do an extension question on quadratic functions. In part A, we're asked to write the expression minus 2x squared plus 5x minus 3 in the form a multiplied by the quantity x plus b all squared plus c. We're being asked to complete the square. With this particular expression, we can see the coefficient of the term in x squared is not 1. What we need to do is factor this out. So I'm going to factor out minus 2 and open up now a square bracket. We'll have x squared. If I divide 5x by minus 2, I'll have minus 5 over 2x. If I divide minus 3 by minus 2, I'll have plus 3 over 2. So all I've done is taken out the factor of minus 2. We can go ahead and complete the square within the brackets. So minus 2, then we'll have now x minus half the coefficient of the term in x, which is 5 over 4. We square the bracket and subtract away minus 5 over 4 squared, which will be minus 25 over 16. We now add to it the 3 over 2. I'm going to write 3 over 2 with a denominator of 16. So multiply numerator and denominator by 8, we'll have 24 over 16. That's just going to make adding these two fractions slightly easier. I'm now going to multiply back through by the minus 2. We'll have x minus 5 over 4, which I need to square. This is going to give me minus 25 over 16 plus 24 over 16 is minus 1 over 16. When I multiply back through by the minus 2, that will give me plus 1 over 8. So in completed square form, we can see now that a will be equal to minus 2, b is going to be equal to minus 5 over 4, and c will be equal to positive 1 over 8. In part B, we're asked to find the points of intersection with the coordinate axis of the graph y is equal to minus 2x squared plus 5x minus 3. So if it's going to cross the y-axis, we can say that x will be equal to 0. If it's going to cross the x-axis, then y will be equal to 0. So what we're going to do is look at solving this equation. We can use the completed square form to find now where y is equal to 0. We could also look at rearranging this. Now what I'm going to do, if we just consider now where it crosses the y-axis first, that's nice and straightforward. All we need to do is sub in x is 0. So y will be 0 plus 0 minus 3. So we can see that that point will be 0, comma, minus 3. What I'm now going to do is look at where it crosses the x-axis, and that's where y is going to be equal to 0. So we'd have 0 is equal to minus 2x squared plus 5x minus 3. We can use the completed square form. So what I can do is simply set this equal to 0 and go ahead and solve. I'm just looking at this now and it looks like it's actually going to factor. So if I now add 2x squared to both sides, subtract 5x and add 3, that will give me 0. Now if I factor this, I could write this as 2x minus 3 and then I'd have now x minus 1 is equal to 0. So we can see from here that x would be equal to 3 over 2 or x would be equal to 1. So we'll have the points 1, 0 and we will have now 3 over 2, 0. Alternatively, if I hadn't spotted that, I can use this completed square form and set this equal to 0. So 0 is minus 2 multiplied by x minus 5 over 4 all squared plus 1/8. Now, if I add this expression to both sides, we will have 2 x minus 5 over 4 all squared is equal to 1 over 8. I'm now going to divide both sides by 2, so we've got now the quantity x minus 5 over 4 all squared will be equal to 1 over 16. If I square root both sides, x minus 5 over 4 will be equal to plus or minus the square root of 1 over 16, which is 1 over 4. Adding 5 over 4 to both sides, we can combine the denominators and we can say 5 plus or minus 1 all over 4 are the solutions to x. So if we do 5 plus 1, x will be equal to 6 over 4, which is 3 over 2. If we do 5 minus 1, that will be 4 over 4, x will be equal to 1. So we can see that the completed square form would help us. Alternatively, what we could have done is set now this equal to 0, divided through by minus 2 and completed the square. So we've got lots of different choices. We now need to find the coordinates of the vertex and state whether it's a maximum or minimum point. If we just consider quadratic graphs, we either have a positive quadratic or a negative quadratic. If we have a positive quadratic, the positive quadratic opens upwards, and this now is the vertex, and this is a minimum point. If we look at a negative quadratic, which opens up downwards, this now is the vertex just here, and this is going to be a maximum. We can use the completed square form and consider graph transformations, and translations in particular, to find out now where the graph has moved from in terms of it being x squared. So all I'm going to think about now is if I've got the graph y is equal to x squared. This point is 0, 0. What we have here are two translations. We have a translation of 5/4 units now in the positive x direction and 1/8 units in the positive y direction. So all we're going to do is move across 5/4 and up 1/8. You could have now used differentiation to find the minimum point, but as we've got the completed square form, we can use this particular approach. So we can say now that the coordinates of the maximum point are 5/4, 1/8, and this now is a max. So all we've done is taken the graph now of y is equal to x squared, and we've considered the translations. There is another transformation, but we're looking here at the translations. We now need to sketch this graph. So we've got lots of information. We've got our maximum point, we've got where it crosses now the x coordinate, we've got where it crosses the y coordinate axis. So the x coordinate axis and the y coordinate axis. So let's go ahead and put our information on. We know that it crosses now the x axis at the points 1 and then 1.5. So I'm going to put these on. It doesn't matter that this is not going to be massively accurate, we'll just have some idea. We know that it passes through the point 0, -3, which is going to be just here, we'll put that there. And then we're going to have the maximum, which will be just here. And again, this now is going to cut the parabola in half. And this is going to be, and we'll just move this to make it slightly more realistic. This is going to be 5/4, 1/8. So we'll put that like so. So here we've got now 5/4, 1/8. So the parabola will open up downwards. That now is the point here. And then we will be symmetric about the line x is equal to 5/4. So this is what we have. This point here is going to be 0, -3. This point will be 1, 0. This point will be 3/2, 0. Or if we like, we could write that now as 1.5. We're not asked for this. I'm going to put the axis of symmetry on. The axis of symmetry is just here. So here's my sketch. It's not massively accurate. This axis of symmetry now is x is equal to 5/4. That's just the x coordinate of the vertex. So we're opening up downwards and we've got all of the information that we need on. So we sketch the graph. We now need to find the area of triangle ABC, where A is a vertex and B and C are the x coordinates of where the graph crosses the x axis. Okay, so what we've got then is this little triangle here. So if we consider now a base to the triangle, the base is going to be now the distance from 1 to 1.5. We've got now a triangle and we've got this symmetric, and then we have now the height. The height is simply the y coordinate. So if we consider now the y coordinate, that's going to be 1/8, and this is quite inaccurate, it'll just give us some idea, and the base is going to be 1/2. So this height here, that's just the y coordinate from the x-axis up to the maximum, which is just here. So this is 1/8, which is the y coordinate. This now is going to be 1/2. The sketch isn't great, but it just gives us some idea. So the area is going to be the base times by the height divided by 2. So we'll have the area is going to be 1/2 multiplied by 1/8, which gives us 1/16, and then we divide by 2. So we can say now that the area is going to be equal to 1/32 units squared. And that now is the area of a triangle. So we've used a few different techniques. With this one, we would just use completing the square. For this one, we had lots of different opportunities or choices to use to find now the coordinate axis, where this crosses the coordinate axis. When we're looking at the coordinates of the vertex, we can use either the completed square form or we can differentiate. I've used the completed square form as the whole video is on quadratic functions. We've sketched a graph and then we've gone ahead and found the area.